Welcome to today's GATE video. Myself, Dr.V.AUXILIA OSVIN Nancy, Associate Professor, Department of Information Technology, A.Engg.College. Today, I'm going to take the topic Asymptotic Worst Case Time and Space Complexity. So initially, if we want to find the effectiveness of the algorithm, we have to analyze the performance. So here, while analyzing the performance of the algorithm, we need efficient and fast, and then we need less memory space. So this can be evaluated by time and space complexity. So what is space complexity? If an algorithm need less number of less space to execution, that is called space complexity, and then time complexity is total amount of time taken by the algorithm that can be calculated by time complexity. And while calculating the space complexity, we need a two part, that is fixed part and then variable part. So what is fixed part is, here we are having independent of instant characteristics. For example, if you are having the variable name, that comes under fixed part. Variable part, so based on that particular variable, if you are going to solve any problem, so that is dependent, that comes under variable part. So we are going to calculate the space by the algorithm by calculating C of fixed part plus variable part. For example, if you are going to take the algorithm of sum of A, B, C, here we are doing the declaration. That means you are assigning the value A is equal to 10, B is equal to 20, and we are calculating C is equal to A plus B, right? So while assigning variable, that takes 1 unit to solve the problem. So it comes under the fixed part. So further calculation cannot be done. So we are going to calculate the space complexity by fixed part plus variable part. So each assignment value contains 1 unit. So A is equal to 10 contain 1 unit, B is equal to 20 contain 1 unit, and C is equal to A plus B. The storage of A plus B contain 1 unit. So totally we are having 3 units. Here we are not going to do the further calculation based on the dependent variable. So that is 0. So 3 plus 0 is 3. And next is time complexity. Here we are going to calculate the amount of time need to complete. So that comes under compile time and then execution time. So for writing the algorithm, so the algorithm heading takes 0 and braces take 0. Expression, if you are going to solve the expression, that comes under 1 unit. For any looping statement, the number of loops, based on that we are going to calculate the time. So for example, for time complexity, we are having 2 types of time complexity, that is constant time complexity and then linear time complexity. So what is constant time complexity? So if you are going to solve any expression, so that comes under constant time complexity. So for example, if you are going to calculate the sum of A, B, so this is the algorithm heading that gives 0. So you are going to calculate A plus B, you are going to solve this particular expression. So we will going to return the value 1. For expression, we are having 1 unit. So in linear time complexity, so we are having certain steps. So the basically comment part, in algorithm part, that is 0. If you are going to assign any value, that comes under 1 step, and for condition statement, 1 step, and if you are going to use the loop condition, then it comes under n plus 1 step, and then body of the loop is n step. So based on that, you are going to calculate the linear time complexity. So here are the example of constant and linear time complexity. So already I told, to solve the expression, the whole expression need 1 unit. So heading takes 0, braces take 0, and for calculating the expression it takes 1 unit and braces 0. So totally to execute this problem, we need only 1 unit. It comes under constant time complexity. And next is linear time complexity example. So here we are having sum of n numbers you are going to calculate. So you are going to pass the 2 values, sum of A, n. So here we are assigning S, sum as 0, and then we are using the loop for I is equal to 1 to n. Already in the previous slide, so we are going to use the loop condition for n times, that is n plus 1 steps. So here For 1 to n, we are going to use n plus 1. For again for calculation, so based on the loop calculation, that is body of the loop, we need n steps. So then return value, it takes 1 unit, totally 2n plus 3 unit to find the sum of n numbers, because here the variation in loop and then body of the loop. So loop condition, it takes n plus 1 unit, and for body of the loop it takes n. So totally the time complexity of this particular problem is 2n plus 3. So what are all the kind of analysis to make the efficiency? So if you want to find the particular algorithm is efficient, so we have to find the analysis of the particular algorithm in 3 ways. That is, if it is in the worst case or average case or best case. So worst case, usually we take the algorithm's worst case because maximum time of the algorithm on any input size. So this is the normal part while analyzing the algorithm. We'll take the particular case. In average case, sometimes we take, because we know the expected time and take the average consumption, we'll analyze the statistical distribution. That comes under average case. And best case is we want to need minimum time of algorithm. So worst case comes under maximum time, and average case we know the expected time of algorithm, and for best case minimum time of algorithm. Okay, so this if you want to make the kind of analysis of the algorithm, that means best case, average case, and then worst case, we are going to calculate that in the mathematical way. For that we need certain notations. So that notations comes under asymptotic notation. So we are going to calculate the running time of the algorithm, and we are going to assign the notation of the particular algorithm. So asymptotic notation tells the growth of the particular algorithm. So we are having certain types of asymptotic notation to analyze the algorithm, that is big O notation, and then big omega notation, theta notation, little o notation, and then little omega notation. So basically we will analyze the average, best, and worst case in 3 cases. If we want to analyze the algorithm for best case, we'll go to omega notation. For finding the average case, we will use theta notation. For finding the worst case, we are going to big O notation. Now we are going to see what is big O, what is omega notation, and then what is theta notation. Okay, so here the mathematical notation, that is asymptotic notation, big O, theta, and then omega assigned based on the calculation of f of n and then g of n. So what is f of n? So already we discussed how to calculate the time complexity of the algorithm, right? So that by using constant or linear. So based on that, we are going to calculate the time complexity of the algorithm, that comes under f of n. So 2n plus 3. Okay, so that if you are going to write the algorithm for finding the sum of n numbers, we calculated the time complexity is 2n plus 3. So if you are going to solve the expression, we find that we need n, right? Okay, so that is the time complexity of certain process, that is algorithm for that particular process. Okay, so that comes under f of n. So f of n is time complexity calculation by an algorithm, and g of n is cumulative time. We are defining whether the particular problem comes under linear or constant, what type of procedure it is going to take. So that comes under cumulative time. So that is fixed. Okay, so f of n is we are going to calculate. G of n is cumulative time, already fixed based on the type of the problem. So if g of n is n, then the particular problem comes under linear complexity. When g of n is 1, that is constant complexity, and g of n is log n, so that particular problem comes under logarithmic complexity, and if it is g of n is n log n, so that is linear arithmetic complexity. If it is g of n is n square, that comes under quadratic complexity. If it is 2 to the power of n, then exponential complexity. Why we are going for g of n? Because we are going to fix the notation based on f of n and then g of n. So f of n is nothing but it is a time complexity calculation done by an algorithm, and g of n is cumulative time taken for the particular set of problems. Okay, so generally if we want to find the efficiency of the problem, most of the problem comes under linear complexity. If it is the complex, then it comes under linear arithmetic complexity. Okay, so here how we fix the notation for big O, omega and then theta. Okay, so if you are going to assign big O of the particular g of n, then the particular f of n should complete this condition, that is f of n, there exists positive constant, so this particular f of n should solve this, should satisfy this condition, that is 0 less than or equal to f of n less than or equal to c into g of n. Okay, and for omega notation, 0 less than or equal to c g of n less than or equal to f of n. So that c represents the constant value, we are going to assign the value. Okay, from that we are going to calculate, so that particular calculation of f of n should satisfy this condition. Okay, then we will assign, if it is satisfies f of n 0 less than or equal to f of n less than or equal to cg of n, then we will consider that as a big O. And if it is 0 less than or equal to cg of n less than or equal to f of n, then we will make the particular notation as omega of the particular complexity. And next is, if it is average of c1 and c2, that is 0 less than or equal to c1 g of n less than or equal to f of n less than or equal to c2 of g of n, then we are going to make the particular notation as theta notation. So these three are the important notations for evaluating the particular algorithm based on big O means worst case, omega means best case, and then theta is average case. And next is little o and little omega notation. It is rarely used notation, but related to gate question, commonly we will use this little o and then little omega. So what is little o notation? So here we are going to solve the condition 0 less than or equal to 1 such that f of 1 is greater than 0. So here the main part is it slows the growth rate, that is f of n grows slower than g of n. So we have to keep in mind this keyword while allocating the notation. Okay, because these three notations grows simultaneously. If f of n grows, g of n also, that is linear. Okay, so the growth rate will be depend on f of n and g of n, that is equally it will improve. But here in little o notation, it grows, it reduces the growth rate, and if f of n grows slower than g of n, so that is if f of n grows slower than g of n, then we are going to make the notation as little o notation. Okay, and for little omega notation, the faster growth rate. Okay, and the condition is f of n grows faster than g of n. So these are the key points we have to remember while assigning little o notation and little omega notation. Okay, so we'll see some example that mathematically solved by the asymptotic. Okay, so the problem given is f of n is given, so we have to assign the g of n. From the g of n we are going to calculate what type of notation can be assigned, whether the particular condition is getting satisfied. Okay, so that is lower bound, upper bound and then tight bound. So lower bound comes under the worst case, upper bound lower bound comes under the best case, upper bound comes under the worst case, and tight bound comes under the average case. Okay, so here the given is f of n is equal to 3n plus 2. Okay, so here this is the time complexity calculated for one algorithm. So that is the given, and consider we are going to consider g of n is equal to n. So g of n is equal to n when the particular problem is getting the complexity of linear complexity. If you are going to solve the problem in linear way, then we are going to assign n as a g of n. Okay, so here if it is 3n plus 2, the lower bound is 3n, the upper bound maximum we can fix is 4n, and tight bound we are going to take the average, so that is 3n. Okay, so according to the definition, so f of n should be less than or equal to Cg of n. So here we are assigning c is equal to 4, so that is the upper band value. Okay, so now calculating, so if you are going to assign n is equal to 2 and c is equal to 4, then we are getting the condition 8 less than or is equal to 8, that solves this condition. Then we can assign, that is 3n plus 2 is big O of n when the particular n value is 2 and the particular c constant value is 4. Okay, so then the condition is satisfied and we are assigning big O of n. Okay, so we need to follow when the particular c value is getting effective. Okay, so if you are going to do that in the worst case analysis, we are going to fix the upper bound value. So here c is equal to 4. So based on n value, we are going to calculate the 3n plus 2. Okay, so we are going to find whether the particular condition is getting satisfied or not. Then if it is satisfied, that is f of n is less than or is equal to Cg of n, then we are going to assign big O of n. Okay, so the next is the same time complexity, that is 3n plus 2. We are going to assign big omega notation when that big omega notation is getting satisfied. So we know already from the definition, f of n should be greater than or is equal to Cg of n. Okay, so here we are going to fix the c value that satisfies the particular condition, that is f of n is greater than or is equal to Cg of n when the particular condition is getting effective, that is c is equal to 1. Okay, so we are getting 3n plus 2 greater than or equal to Cn. When we are assigning value to n, then we are getting 5 greater than or is equal to n. So the condition is getting satisfied, then we are assigning big omega of n for the particular time complexity. Okay, and next is average case. In average case, we are going to consider C1 and C2. Okay, so based on the C1 and C2 value, the particular condition should be satisfied. That is C1 g of n less than or is equal to f of n less than or is equal to C2 into g of n. Okay, so that is 3n plus 2 is equal to theta of n. So let us discuss some gate questions here now based on the particular topic, asymptotic notation. Okay, so this question is taken from the set question paper set 1 2024. Okay, so they have given, that is given integer array of size n. Okay, so we want to check if the array is sorted either ascending or descending order. An algorithm solves this problem by making a single pass through the array and comparing each element of the array only with its adjacent element. So they are asking for the worst case time complexity. So the worst case time complexity comes under basically big O notation. Okay, so here we are having the certain options, right? Okay, so while finding the notation for ascending or descending order, we are going to sort the array from starting point to end. Okay, so for this, if we are having the worst case is nothing but we are going to compare the each element with the adjacent element. The two cases are given. Okay, so that by making a single pass through the array, if the sorted element is there also, we are going to sort the entire array. Okay, so that comes under big O of n. Okay, so if it is already in sorted array, that comes under the best case big omega of n. So both the worst case analysis comes under big O notation and as well big omega notation. So the possible option is we can consider both big O of n and big omega of n. Okay, so here the next problem, this question taken from 2023 gate question. So consider function 1 and function 2. Okay, so this is one function and this is another function. It has the condition, loop condition, I is equal to 1 to n, x is equal to x plus 1. So the question is, let f1 of n and f2 of n denote the number of times the statement x is equal to x plus 1. So we are going to find the statement x is equal to x plus 1 execution time. Okay, so here we are having the we are going to find out which are the statement is true. F1 of n belongs to theta of f2 of n, or f1 of n belongs to little o of f2 of n, and then f1 of n belongs to little omega of f2 of n, and f1 of n belongs to big O of n. So the explanation is given here. So in first option, function 1, so we need f1 of n will take time, that is each time that n is assigned to n by 2, so f1 of n will take the time, that is n plus n by 2 plus n by 4 plus n by 8. So this comes under the geometric series. Okay, so for that notation we are going to assign big O of n. So this particular function takes the mathematical notation of big O, so that is the maximum time f1 of n belongs to big O of n. Okay, so and also it comes under the tight bound, that is average case, so f1 of n also belongs to theta of n. So the option 1 is true. And for function 2, the same statement, f2 of n is there 1 into n, here 100 into n. Okay, so the same notation is comes under for f2 of function. Okay, so then option A is f1 of n belongs to theta of f2 of n. So the option A is getting true because f1 of n belongs to big O of n, f1 of n belongs to theta of n. Okay, so f2 of n also belongs to theta of f2 of n. So the particular option is true. And we are analyzing the second option, that is little o. So little o means what? So this one is f1 grows slower than the f2, that is we are assigning little o means it slows the growth rate. Okay, so this option getting false, that is option B is false. And next is option 3, option C, f1 of n belongs to little omega of f2 of n. It increase little omega means the function grows faster. Okay, so this option also getting failed. So that is option C is false. And next is option D, f1 of n belongs to big 1 of n. Already we discussed in the first option itself. We are assigning the function 1 belongs to big O of n. So option D is true. So option A and D is true. And next is we are taking two arrays, that is this question is taken in 2019. Unsorted array, we are having unsorted array. Assume that n is odd number and each array contains n distinct elements. Okay, so there are no common elements between these two arrays. So first we have to calculate the worst case asymptotic notation for computing the median of the median. The median of the median. So A1, A2 to AN. So we are having certain options, big O of n, big O of n log n, big O of n square, and then omega of n square log n. So here the total number of elements in each row. So total number of elements in each row, n elements in each row. So to find the median of the particular n elements in each row, it takes big O of n time. Okay, if your going to use that for n row. So the first statement is total n elements in each row. For finding the median of the particular thing, we need big O of n time. Okay, so total n row, so we are going to calculate the total time n into big O of n, that is big O of n square. So if you are going to find out the median of m, it will take again big O of n time. So the total time to calculate for n row, that is big O of n square, and then for median of m, it takes big O of n. Finally we are getting big O of n square. And next is, this is the following C code they have given. We are going to find out the asymptotic notation of the function in terms of theta notation. Okay, so here, so this particular loop comes under the n log n notation. So each iteration we are going to calculate in the base of log n minus 1. Okay, so first iteration is n minus 1 by 1 plus n minus 1 by 2 plus n minus 1 by 3 to 1, and next is n by 1. So from this series we are going to assign n log n minus 1 log n minus 1, and then finally we are getting n log n. Okay, so to compute this problem, we are going to take the theta notation. Theta is the average notation of n log n. Okay, so this is all about the asymptotic worst case on time complexity and space complexity. Thank you S.A. Engineering-College for giving me this opportunity to complete this topic, and we'll discuss more problem in the next session. Thank you.